Welcome to the DIY Honda Garage channel. The DTC P0502 indicates a problem with the continuously variable transmission CVT speed sensor circuit, which the transmission control module, TCM, uses to monitor the vehicle's speed. This issue arises when the TCM cannot accurately detect the signal from the CVT speed sensor while the secondary driven gear rotates. The failure of this sensor can lead to improper transmission function, since it is crucial for the engine management system to optimize gear shifting and overall drivability. CVT stands for Continuously Variable Transmission, which allows the engine to operate more efficiently by providing a seamless range of gear ratios. The TCM, often located near the transmission assembly, relies on several circuits, including VCC3, VEL-PWM, and SG3, for the smooth operation of the transmission system. If the TCM detects an issue with the CVT speed sensor, it triggers this diagnostic trouble code, indicating an abnormal condition in the sensor circuit. The DTC P0502 primarily concerns the CVT speed sensor, an essential component that provides data about the vehicle's speed to the TCM. The TCM, or Transmission Control Module, is responsible for controlling the transmission operations, including gear shifts. Given that the CVT speed sensor is directly linked to the vehicle's secondary driven gear, its location is critical for accurate readings. When the TCM cannot detect the sensor signal, it might lead to suboptimal performance, including delayed gear shifts and potential engine stalling. Because accurate speed information is vital for engine management and performance tuning, this fault code necessitates prompt investigation. Understanding the role of the CVT speed sensor and its interaction with the TCM is crucial for resolving this issue effectively. The potential causes of the DTC P0502 include several pivotal components that might malfunction. Firstly, the CVT speed sensor itself may be defective. As the primary interface for speed readings, any failure in this sensor can lead to loss of vehicle speed data. Secondly, circuit issues can also trigger this fault code, such as open or short circuits in the wiring connecting the sensor to the TCM. These circuit problems could manifest due to wear, damage, moisture intrusion, or improper connections. Lastly, a malfunctioning TCM could cause the error by failing to interpret or receive the signal from the CVT speed sensor correctly. Therefore, diagnostics must focus on these components to identify the underlying reason for the DTC. The DTC P0502 may lead to various noticeable symptoms that drivers encounter. One common symptom is transmission performance issues, where drivers might experience rough or erratic shifting. This can manifest as hesitation or delays, especially during acceleration, as the TCM struggles to receive accurate speed data. Additionally, the vehicle may exhibit shifts that feel harsh or unexpected, causing uncertainty in drivability. Another significant sign is the activation of the check engine light on the dashboard, which alerts the driver to a potential issue requiring immediate attention. Finally, in severe cases, the vehicle may enter a fail-safe mode, limiting acceleration and overall speed to prevent further complications, making these symptoms critical to address quickly. The first step in troubleshooting DTC P0502 requires the vehicle to be raised on a lift securely. This is essential for safely accessing the undercarriage and components involved in the transmission system. Once elevated, it's important to ensure that all four wheels can rotate freely, as this allows for accurate testing of the transmission behavior during the diagnostic process. Following this, the Vehicle Stability Assist, VSA, must be disabled to prevent it from interfering with the performance diagnostics related to the speed sensor. Disabling the VSA system ensures that any anomalies detected are solely attributed to the speed sensor, rather than being masked by the stability system's controls. In the second troubleshooting step, the engine must be started after securely raising the vehicle. It's crucial to set the vehicle's transmission to the Drive D position to simulate normal driving conditions. While doing so, the technician should ensure that the engine speed is maintained at 1,000 RPM or higher. This step is significant because it allows for the CVT to operate under load conditions, which can help determine whether the TCM receives the appropriate signals from the speed sensor while the vehicle is in motion. By maintaining steady engine speed, technicians can properly analyze the performance of the vehicle and its components during the diagnostic process. The next step involves carefully releasing the accelerator pedal after maintaining 1,000 RPM for a sufficient time. The technician should observe the vehicle's behavior for at least 4 seconds during this release phase. This observation is crucial as it allows the TCM to respond to the changes in speed and determine whether it accurately recognizes the signals from the CVT speed sensor. Following the observation period, it's important to bring the vehicle to a complete stop to check if any error codes or transmission faults arise during the deceleration period. This test helps identify malfunctions with the speed sensor, as it is designed to provide consistent feedback to the TCM in real-time driving conditions. In this step, the technician will disconnect the 3-pin connector of the CVT speed sensor for a thorough inspection. This disconnection is a preliminary step to ensure safety and accurate measurements. The inspection involves examining the connector for signs of wear, corrosion, or damage that may disrupt electrical connectivity. Once the connector is verified, the next action is to measure the module output voltage under the ignition mode, IG. Confirming that the sensor outputs approximately 5 volts consistently. This measurement is vital as a normal voltage reading indicates that the sensor is likely functioning correctly. However, if any abnormality is noted in the voltage output, it points toward a potential failure of the CVT speed sensor itself. For this crucial step in troubleshooting, the 50-pin 50P connector of the TCM must also be disconnected to examine the communication state between the sensors and the module. Before this, it's important to jump the short-circuiting line, SCS, with the Honda Diagnostic System, HDS, and wait more than 1 minute to allow the system to reset and stabilize. Post-reset, technicians should analyze the outputs of the VCC3, VEL PWM, and SG3 circuits for continuity, ensuring they measure less than 1 ohm. Each of these circuits plays a vital role in relaying critical information from the speed sensor to the TCM. Any abnormalities in these readings indicate faults within the wiring or connections, leading to an electrical short or open circuit that must be addressed promptly. The subsequent step involves a detailed inspection of the wiring connected to the CVT speed sensor, TCM, and associated circuits. Technicians should look for any signs of shorted wiring, as this can lead to failure in sensor signal transmission. Additionally, ground connections must be verified to ensure they are clean and secure, as poor ground can result in intermittent signals or complete loss of function. Aside from checking for shorts and grounds, it is crucial to examine for open circuits, where the wiring may be broken or disconnected entirely. These inspections are essential in narrowing down the root cause of the DTC P0502, allowing for effective repairs to restore proper sensor functionality. In the final troubleshooting step, the focus shifts back to the CVT speed sensor itself, especially after ruling out issues with wiring and connections. Technicians will need to inspect the sensor thoroughly for any physical damage or signs of wear that might impair its functionality. Testing should also include measuring both the voltage output and resistance of the sensor to determine its operational status. Normal readings should align with the manufacturer's specifications. Deviations may indicate sensor failure. If the sensor consistently tests outside of normal ranges, it is likely the source of the DTC P0502, and replacement of the sensor would be necessary to restore proper performance capabilities. After completing the necessary repairs and component replacements, it's essential to conduct a final verification to ensure that the DTC P0502 has been resolved effectively. This involves first clearing any diagnostic trouble codes, DTCs, stored in the system, allowing the onboard computer to reset. Following this, a recheck should be performed to ensure that no new error codes reappear in the system. Finally, a test drive is critical to confirm that the vehicle operates correctly under normal conditions, ensuring that smooth gear shifts and accurate speed readings are restored. Observing the vehicle's performance during this test is essential in validating the effectiveness of repairs made and guaranteeing that the underlying issue has been resolved. In summary, DTC P0502 highlights the significance of the CVT speed sensor in modern Honda vehicles as it plays an integral role in maintaining optimal transmission performance. A malfunction can lead to various performance issues, including erratic shifting and reduced drivability. Therefore, it is crucial to conduct thorough inspections of the wiring and connectors to ensure the integrity of the signal being transmitted to the TCM. Each step of the troubleshooting process contributes to isolating the issue effectively, whether it stems from the sensor, wiring, or TCM. By adhering to systematic procedures and verifying repairs through road testing, technicians can ensure that the vehicle operates safely and efficiently, restoring driver confidence in their Honda Civic. Please like and subscribe to the channel. See you next time.